Good evening, everyone. Welcome once again to another session where we provide some kind of training to senior students in order that they can participate in Olympiad type problems. This particular session is directed more towards those who have qualified to round 3 previously, who have shown some degree of expertise in mathematics and problem solving especially. And I am very grateful that you are coming here despite the fact that all the South African Maths Foundation competitions, namely the SAMO, the Olympiad, are all over. It goes to show that you are still interested in learning how to solve problems. There is also the forthcoming team event. This is, I think, this coming weekend, or maybe two Saturdays from now. And I'm sure some or many of you will be participating in that. All the best for that team event as well. Okay, hopefully you have learned sufficiently much to perform somewhat reasonably, at least in that team event, if your school is participating in it. If you want to know more information about that, you can go into the South African Maths Foundation website, and that will give you more information. All right, with those few remarks, I think we can proceed. I want to bid a special welcome to Khotso and as well as Brad. Welcome, Brad.
How's it, Prof? How's it, guys?
Okay, good. Hope you enjoy the session. All right, so we are now going to go straight into this program. Let me just see where are we? Sure. Okay, Khotso, can you confirm that you can see the board or the screen?
Yes, I can see the board.
Okay, thank you so much. All right, we go straight to question 1. Question 1 says the following. The diagram shows 2 parallel lines with 6. Oh, I think we have already done this. Last week, we started with these problems and we didn't complete them. And then, unfortunately, we had to abort the program because of a glitch. So this particular problem, I think we had solved, so I'm not going to do this. So what we can do is go straight to question 2. All right, question 2 says the following. Consider an 8 by 8 empty chessboard with 64 squares. The chessboard is drawn there. In how many ways can you place one black rook and one white rook on 2 different squares that are on 2 different rows and 2 different columns? All right, you need not know about what chess is. You need not know how to play chess. What this question says is that you've got 2 pieces, 2 chess pieces on this, and these 2 pieces, one is a black piece and the other is a white piece, and these pieces are placed in such a way that if I got a black here in this square, for instance, then they are placed on 2 different squares, on 2 different rows and 2 different columns. In other words, the next one cannot be placed in this row or this column here, which I'm pointing to. It has to be on a different column. Let's call it white. All right. So the question is, in how many ways can you do this? Where you can take 2 pieces and place them like this. Okay, in just language, these pieces cannot cut each other. All right. Now, we have already seen the way this thing works. When you are counting, one of the ways I normally do it like this. One of the ways of counting is I want to know how many items should I be counting. And here I have to make two choices. The first choice is to choose one of the rooks. It doesn't matter which one. Let's say it's black, and place it on this chessboard. And the question is, and how many ways can I place it? Well, if the chessboard is empty, there are 64 squares, so you can place the black one in 64 ways. Right. Now, once the black is placed, then the white now needs to be placed after the black one has been done. And you want to know how many ways can you do that. This time you're not allowed to include any of these, any of these and any of these. Now, if you cross out all these squares, I'm just going to do that. Cross out all the squares in which the black occurs, and you're not allowed to put the white there. You can see the white is spaced in one of them. Then in how many ways can you place the white? You will see that it's actually 64 minus, it should be 8 plus 8, which is 16, but it's not really that because this B will be counted twice if you do that. So it's 64 minus 15 actually. So it's 49. So you can place the two rooks in the first one in 64 ways, the second one in 49 ways. And therefore, the way we normally do this is you multiply these numbers in this rectangle to work out the total number. Okay, 64 times 49 is 56 squared, which is 3136. So the main thing is that, and how many ways can you place the first one, how many ways can you place the second one, and so on and so forth, and multiply all of them together. And this is a fundamental principle in counting, right? If there are several things that you have to count, one of the ways of doing that is to find out how each one, the number of times each one can be counted, and multiply them together. Okay, but you have to, it doesn't apply like that all the time. You have to decide when you're going to use that principle. All right, so the next one is, okay, this one here is very similar to what we have done. And I think it's the kind of question that you can ask even in school when you do at grade 12, grade 11, when they do counting and probability. This is in the syllabus, by the way, counting and probability. So this is one of the first things you learn. I have 5 books, one of each color. In how many ways can I place them in a row? All right, so you got 5 books, and you choose one of each color. You got maybe A, B, C, D, E. These are the colors. We don't know what the colors are. We'll simply call them A, B, and A, B, C, D, E. So suppose I place the first one A. In how many ways can I do that? I can do that in 5 ways. I can take any one of these and place them. So once I've placed it, then that is out. Now you've got 4 to choose from. You choose any one of these, and that can be placed in 4 ways. You're not allowed to place it there. So the second one can be placed in 4 ways. So that is out. And now you only got three slots to place, and you take the third book, and you can place it in any one of 3 ways. So like that, you get this. So the number of ways in which you can place each book is given in this thing, and therefore the number of ways altogether is just the product of all. Five times 4 times 3 times 2 times 1. And you'll recognize this to be the same as factorials. So if you multiply all these together, you get 120. So this is the same as 1 times 2 times 3 times 4 times 5. 1 times 2 times 3 times 4 times 5. And we have the symbol 5 with a exclamation mark like that, which means 5 factorial. All right. I presume you are familiar with this because all problem solvers at some time or the other they will come across this symbol where you have that a number n factorial is simply the product 1 times 2 times 3 all the way up to n. And this n here is the last one. If you multiply all of these, then you have a single symbol called n factorial. All right, and the first few factorials, you know, 1 factorial is 1, 2 factorial is 1 times 2, 1 times 2 times 3, 3 times 4, 5, and so on and so forth. These are the first few factorials, and the 5 factorial is 120, as you can see, and that's the answer to that question. Okay, now that takes me to the next problem, which is here. It says how many positive 4-digit numbers, 4-digit integers. All right, they are positive integers because they are between 1,000 and 9,999. See, integers can be positive or negative. So when they use the word integers, it could be negative or positive. But here, because it's this, the positive integers are also called natural numbers. So the question is, how many of these are there that are divisible by 5 with every digit even? Okay, so these numbers are divisible by 5. So that's immediately, you should be able to fill one square. And now it's a 4-digit number, so that is why I've got 4 spaces here. I have to fill in these 4 spaces for each of the 4 digits, right? So an example of such a digit will be, you want every digit even, so you can have the first digit is 2, maybe, the next one is 8, and the next one is 4, and it's a divisible by 5, or the same as saying it's a multiple of 5. And if it's a multiple of 5, the last digit is either 0 or 5, but it can't be 5 because 5 is odd, right? So they say every digit is even. So the last digit has to be 0. All right. So now that helps a great deal. It means that the last digit can only be 1. There's only one way to fill the last digit, namely it has to be 0. Okay. All right. Now you want to fill in even numbers here. Now, what digit can you put here for? Let's start here at the front. It must be an even digit, so it could be any one of 2. Well, 0 is even also. 0, 2, 4, 6, 8. I remember somebody once asking me, why is 0 even? And I said, well, simply because if you add 1 to it, you get an odd number. Right? So if you can't decide that, just add 1 and see what's the next number. It's an odd number, so this has to be even. Okay, so now the first digit can't be 0 because it's a 4-digit number. A 4-digit number can't start with 0. So the first digit could be any one of these. So there are 4 possibilities for the first digit. But now, there's nothing said about it. That repetitions are not allowed. So the second digit is going to be even, but it can't be 0. No, I mean, it can be 0. Now it can be 0. So you can have 4, 0, 4, 2, 4, 4, 4, 6, 4, 8. So there are 5 ways in which you can fill the second digit. Any one of these 5 can fill the second digit. And likewise, any one of these 5 can fill the third digit. So, and the last one can be filled in one way. So therefore, answer is a number of ways. We filled in the blocks here. So all you have to do is to just multiply these. And that's 25 times 4, which is 100. So there are 100 such digits, numbers between 1,000 and 9,999 inclusive. Okay. This is a beautiful way of doing things. Otherwise, suppose you didn't know this principle, then you'll have to count every one of them. You can't start with 1,000, you'll start with 2,000, and you get 2,000 is certainly one of them, and 2002, and so on. So that will take you a long time to count to the whole 100. So here, mathematics is so powerful, you can get the answer in just a few minutes, a few seconds, rather, by applying this principle that you find out how many times you can multiply, choose each one of them and multiply them together. All right, so we get on to the next problem, which is question number 5, which okay, now it's getting a little bit tough now. So all the words that can be formed from the letters A, H, M, S, T are written down in alphabetical order and are numbered 1, 2, 3, 4, etc. Which number in the list is the word maths? Now, this one here is not the same as, now you have to think about this now. All right, so this is a creative question, and you have to count each time because you got a list 1, 2, 3, 4, and so on, right? And you are going to write down all these numbers in alphabetical order. Now you can see A, H, M, S, T, already that is in alphabetical order. It's like building up a dictionary. So you got the first one is A, H, M, S, T. All right. The second one will again start with A, H, M, right? And here you'll have to put TS. Right? And the third one will be A, H. Now the M is finished here in the third one, so you can put S now. Right? And then you put MT. Like that. Okay, so now the question is how many words at which position in all this is maths? That's the number. Right. Now, the way to count this is let's finish all the ones with A's, all the ones which start with A's. Right? So the ones which start with A's, then you can put any one of the 4 remaining letters in any order you like. Right? So if you start with A, sorry. If you start with A, then the remaining letters oh, right. So this can be chosen now in any one of 4 ways. Right? You can't repeat A, obviously, because you got this. This can be chosen from any one of these. So there are 4 ways of choosing that. Once you choose that one, AH, for instance, then the third one can be chosen in 3 ways. Right? AH have already been chosen. And the fourth one in 2 ways. And once you choose the whole four of them, the last one is only one way you can choose that. So the ones which start with A, there are 24 of them, right? Okay, so the 25th one will start with H, right? Because the A's would have been finished. So you do the same thing for that one. The 25th one starts with H. It means that you got exactly the same argument to say that the remaining four letters can be chosen again in 24 ways, right? So you got the first two is you come to 48, and the 49th one, 48 starting with A and H. The 49th one will start with AHM. Now we are there, almost there. So the 49th one starts with M. And now maybe we can write the 49th, 50th, 51, 52. All we have to do is to just build up a dictionary. All right, so you got M. With M, you have AHST because this increasing order. MAHST, right? Okay, then you still have MA, and you have HTS, MA, H. Oh no, A is finished now. So you have MAS. Sorry, after H you get S. You're not allowed to use M again. And if you got S, you got MAS, you have H and T left. So H comes before T, and you have MAS, and then T comes before. Yeah, after this. And then the next one, now we finished MAS, the next one will be MAT. And once you take out MAT, you're left with H and S only. So HS will, oh, there we are. So HS is this. So the number that we're looking for is 53. So the 53rd number in this list will be mathematics. Okay, so that's an interesting question where you actually count by understanding the question and count it in a systematic way. You have to finish the A's and finish the M's, finish the H's, and so on. All right, so that takes care of the next problem. And we now go on to all right, so you're looking at this one here. So the next problem is this. It says that there are 10 parking spots in a parking lot at the back of the administration office. All right, so there are 10 spots, the parking bays. 6 teachers and the principal need to park here. So I've drawn the parking spaces here, but you'll see I colored the yellow. Why do I color the yellow? The principal always gets one of the 4 spots with the shade. Oh, this is one of those principles. He wants the best parking space. So there's a tree here somewhere. And this is a shaded area, and the principal parks in one of these. All right. And then the rest of the teachers, the lower class population, can go and park elsewhere. Right? They don't. Some of them will get the shade, right? And the others will have to be suffering in the sun. Now, how do we do this? Now, how do we find out in how many ways can all 7 cars be parked in the lot? So that is the question. So you got seven places to fill. So I'm going to put in my 7 spots here. I think I've got 7 there. All right. Now, how do we fill this? I think the best thing to do is to put the principal in first, then we don't have any problems. Okay, let's give him the pride of place. He can go and take his parking space. And he will choose one of these parking spaces. So there's only 4 spots that the principal will fill in. But once he gets in, right, so this is a big guy, principal, then there are 9 spots. No, wait a minute, 6 spots. Yeah, there are 6 teachers. Oh, yeah, okay, right. There are 6 teachers, and these 6 teachers can fill in any one of these 9 spots. There are 8 spots altogether because, no, okay, there are 9. There are 10 parking lots altogether. The principal has already taken 1, so there are 9 positions here. So the first teacher will come, he's got a choice of 9, any one of them, right? So once he fills it in, the next guy who comes in will only have a choice of 8, because two lots are already filled in. The next one will be 7, 6, 5, 4. So the last guy will have 4, any one of 4. He's got 10 parking spots, so there will be 3 which remain after the 7 people fill it in. So he takes one of those 4, the 3 will remain. So you have to multiply all these big guys, yeah? And without a calculator, it's going to be quite a tussle. Anyway, so you have to multiply this thing. I think if you multiply these 4 with 840, and if you multiply these 4, you get 288. So it's a multiplication sum, which you can do perhaps by longhand. Okay, so that's the answer to that question. So let's get on. So all these so far, they involve counting, and today's session is all about counting. I think counting and maybe a little bit of geometry. I'm not sure how it goes. So we are now on question 6 and question 7. Let's choose that. Okay, so again, this is a counting problem. If you write the integers 2, 3, 4, 6, 8 in every possible order to form 5-digit numbers, how many of these numbers will be divisible by 11? You see, people often ask me, what are the formulae? There's no formula. In problem solving, there's no formula. Very rarely do we use formula. What we have to do is understand the question and try to solve the problem given the information in that question. Occasionally, there will be formulae, but in most cases, you should not rely on formula unless you have to. But you try to use first principles the way I do. Okay, so you got 5-digit numbers. So we'll have to fill in 5 spaces for as a starting point. Okay, so let's just fill in these 5 spaces. Okay, now what do they say here? You're going to put only these digits here, 2, 3, 4, 6, and 8 into this. right? Please don't say you say that the first one can be chosen in 5 ways, and so on and so forth. If you put all the possible combinations, there are 120, as we saw before, 5 factorial ways of putting all the possible combinations of these. But that is not really what they say here. They say, how many of these will be divisible by 11? All right, now this tests also divisibility by 11. So how do you know whether a number is divisible by 11? Let's take a number like 4,398, right? Now, the way to check divisibility by 11 is by adding the alternate numbers, 4 and 9. Starting from 4, miss 1, add that, and then take the other set of alternate numbers. You may have more numbers here. Then you add these, right? Now, if you add these, you get 14, 491. And if you add these, you got 19. So then when you add these alternate numbers, you get these two sets of alternate numbers. Then you get two different numbers. And the way to check to see whether it's divisible by 11 is to subtract those two numbers, right? The smaller one from the larger number. And if you get 0, in other words, if they are equal, it is divisible by 11. Or if you subtract them and you see that it is 11, again, it is divisible by 11. Or 22. In Kosinati, you raised your hand. I'm not sure why you did that, but can you please ask your question at the end of the session, and then I will answer it, okay? Unless you're correcting me as I'm going along. Okay. If you make a correction, that's fine. But make sure that is the correction. Don't waste my time. All right. So you got, I think 491, that's 14, and this is 19. Now, yeah, you can see when you subtract these two, you have to get a multiple of 11, including 0. Okay. Then you know that that number is divisible by 11. Now, I'm going to explain quickly why that is the case. Because if you take very, very quickly, because I don't have too much of time, 3192, for instance, right? If you write this thing as 3,000 plus 100 plus 90 plus 2, right? Then you'll get 3 times 1,000. Now, 1,000 is 1,001 minus 1. And 100 is 99 plus 1. And 9 times 10 is 11 minus 1. And plus 2. Now, this thing here, 1,001 is 11 times 91. This is 11 goes into this exactly, right? So you got 3 times this. If you expand this, you got 11 times some number. 3 times, because 11 goes into this. 11 times 91 times 3 is 11 times number. Right. Now, I'm just going to ignore this for the moment. There's 99 here. So that's 11 times 9, right? And here you got 9 times 11. Again, you got 11 times 9. So you got 11. These three give you multiples of 11. So if you put them all together, you'll get 11 times the multiple of 11. The only things that you are missing are the minus 3 plus 1 minus 9 plus 2. Now you take all the second ones. And so this is 11, a multiple of 11. If you want this to be a multiple of 11, you will need to have that this is a multiple of 11. But when you do this, you will see you got 1 plus 2. Now you watch 1 plus 2 That is one of the sums we had. And the other one is 3 and 9. 3 plus 9 is 12. So when you work out that, you're going to get 3 minus 12, right? I'd rather take 12 minus 3, but that is not a multiple of 11, right? This actually gives you the remainder when you divide this by 11, because whenever you're dividing something by 11, it's 11 times something plus whatever the remainder is. But, well, nearly the remainder, because the remainder has to be some positive number between 0 and 11. We wouldn't worry about that for the moment. But if this is a multiple of 11, then the number is... All right, so now here you got the alternate digits are this. And we don't know what these numbers are. Let's call them A, B, C, D, E. Right. They are coming from 2, 3, 4, 6, 8. I'm not putting the numbers down. I'm just going to call them symbols and see what we can do with them. Now, we know that A plus C plus E, A plus C plus E, that's the alternate sum. And here the other alternate is B plus D minus B plus D must be a multiple of 11. All right, so this is where we are. We are going to fill these things up in such a way that when you work out the alternate sums and subtract them, then you're going to get a multiple of 11. Now the question is, how do you break these 5 numbers in such a way that 3 of the numbers minus the sum of the other 2 gives you a multiple of 11. So I'm just going to put those in some blob here. I'm going to put 2, 3, 4, 6, 8. And let's take them 2 at a time. Right. If I take 2 and 3, so B and D, suppose they are 2 and 3. That's 5. 6 plus 8 is 14. Plus 4 is 18. 18 minus 5 is 13. So that doesn't work. All right. So we can say that 2 and 3 don't give you the B and D cannot be 2 plus 3. All right. The other way of doing this is if you add up all these things, you got 6 plus 8 is 14, 18, 21, 5, 9, 23. So you want 2 groups such that the one sum minus the other sum is okay, I think that's a nice way of doing it. I want to break this thing up into 2 groups. Say like that. I'm going to call it A and B. We know that A plus B is 23. Because if you add up all the numbers, we already know what it is. But we also know that A minus B is either 0 or 11 or 22. Well, obviously, it can't be as much as 22 because these are all very small numbers. And A minus B is not going to be anywhere near that. And A minus B could be 0 or 11. But then you will have, if A minus B is 0, then A must be equal to B. So when you add up all these things into 2 different parts, you wouldn't get A equal to B. You never get one group equal to the other. Or you can't have A equal to B, because then in that case, this will be even. Because A plus B will be twice A. So A can't be equal to B. So this is not 0. So it has to be 11. Right, so if that is 11, let's now we got 2 equations with 2 unknowns. And we can actually, what I need to do is to calculate B. So when I subtract, I want to calculate that. That's easier to calculate. So if you subtract, you get 2B is equal to 23 minus 11. And that's 12. So B is equal to 6. Oh, I see. So how nice it is to do mathematics. You can actually use mathematics to find out which two, how to choose these two. So we got the sum of these two numbers B and D is 6. Right? So that is why this 4 plus 8 is wrong. Now, how can you get 6? The only way you can get 6 is 2 plus 4. All right. So we have to now that limits our things to 2 and 4. And I'm going to now I'm going to put 2 and 4 here. And see, that'll help me to do the counting. Okay, I'm going to put 2 and 4. 2 plus 4. That's your B. We're adding two numbers. Oh, by the way, it could be 4 and 2. So we must just be a little bit careful. We got this. And we can also have 4 and 2. But let's just do it like this first. So how many numbers are look in this form? Now you have to put the remaining numbers, 3, 6, and 8. You have to place them here. 3, 6, and 8. You can place them anyhow you like. You can put an 8, a 6, and a 3, or 6 and 8 and 3. The important thing here is that when you add these and subtract these, you're going to get 11. And that will make it a multiple of 11. So in other words, these 3 can be placed in any way you feel like, right? The first one can be, by the way, this is it's actually wrong what I've written here. I'm looking for a 5-digit number, right? So I'm looking at it like this. So this is, let's not get confused. I'm looking at a 5-digit number. And these 3 digits now can be filled in 6 ways. Because you can take any one of 3, 6, 8. You can make it 386, 638, or 683. So there are 836 and 863. So you should see. So there are 6 numbers which look like this. All right. And then, so that's it. There are no more which have 2 in the second digit and 4 in the fourth digit. So let's remove that one and try the other one now. So the other one was 4, 2, remember? And again, you'll have another 6 here. So there are 6 ways here as well. And that's it. These two can only be 2 and 4, right? And we have exhausted all the possible counting ways. So the answer is the 6 in the first case and 6 in the second case. So it has to be 6 plus 12. So it's not a question of just multiplying and by having some formulae like the way we did in the early questions. You have to think about these problems, and you get very interesting questions like the way we just had them now. So the answer to this problem is 12. There are only 12 numbers which have this property. Okay, so let's get on to the next question. Okay, let me open this thing out for discussion here. I think somebody asked a question. Are there any questions up to this point? All right, so it seems in Kosinati, yeah. Talk to me. Put your microphone on and
sir.
ask.
Good evening, sir.
Good evening.
I wanted to ask on question number 6, sir.
Yes. What is the question you asked?
You said I get it there 10 parking lots, 4 with shade and 6 without shade.
Yes.
And then there are 7 guys who are going to park, the principal and other teachers, 6 other teachers. So
yes.
You said the principal will have 4 possible ways in parking, which we had our first number, which was 4. Then you said the second guy has 9. He has 9. But I was asking if What if the second guy also wanted the parking place with shade?
Yeah, that includes 9, because we said there are 9 possibilities. The principal has taken his place, and the remaining of the remaining ones, 3 of them have got shade and 6 of them got no shade. I think your question
So
is he allowed to park in the shaded spot? I think that is your question. Is the teacher allowed to park in the shaded spot? Is that your question?
yes, sir. Yes, sir.
Yeah, okay. No, it will be a very, very selfish principal who says that he wants all 4 parking lots for himself, right? He can,
Yes, sir.
maybe the question is expects that. You may be right, because why did they give you 10? They are saying that the teachers will have to park in the sun, every one of them. They got no choice. And I think
Yes.
if the principal has chosen his parking lot, if the principal has chosen his parking lot, then the teachers can be chosen in any one of those 9 ways. But I think you may be right, because I, I think the way it will work is that the teachers come in there and they see I've got 4 parking lots for the principal, and as long as they don't they leave one for the principal all the time, then they are safe, you know. So the principal, yeah. So it doesn't really. But they will always have 9 times 8, and even if all the 3 of the yellow parking lots are taken, the last guy who comes is not allowed to park in that lot. He can any one of the other lots. All right,
Yes, sir.
but that's a question. And please put your uh, mic off now, because there's a lot of noise. I hope that answers your question. Thank you for the question. It's a good question. Are there any other people who are asking a question here? I hope that answers in Kosinati's question. All right, so let's go to the next one. I think you will agree with me that once the principal is parked, the teachers can park in any one of the other places, unless it's an extremely selfish principal who says that those parking lots are, very special only for him. Let's get on to the next question, which is question number 8. The question number 8 says the following: how many 3-element subsets are there? Does a set of 8 elements have? Now, I'm going to give a little lesson here. It's a very, very, very important question. This is: how many subsets does a set have having 8 elements, all of which have got only 3 elements in it? That's much deeper than what it appears to be. See, let's take a smaller case. Suppose you've got 6 elements, A, B, C, D, or maybe 5. All right, and you want to work out how many 3-element subsets are there. All right. Now, if I to take the 3-element subsets, I have to eliminate 2, right? So I'll have to eliminate 2. So I can eliminate AB, in which case, now the sets are always written in braces like this. So if I eliminate AB, then I'm left with CDE, and that's AB. Now let's do AC, BDE, and then AE, I've got BCD. I'm taking a simpler case where you've got 5 elements and you've got a 3-element subset. And I want to see what the pattern is so that I can apply it to this 8-element set. Just to make the problem a little bit simple so that I can understand how do we do the counting. Okay, so if you take out the AB, you got the 3. Okay. Now you can take out the AC. All right, so in other words, I actually have to count how many there are like this: AB, AC, AD, AE. Remove these and those other three will give you a 3-element subset. Or you can start with B. Don't include A anymore because we've already done that. You got B, C, B, D, B, E. If you remove those, then you will have another 3 new 3-element subsets. Or you can start with C. Then you got C, D, C, E. And then you have 2 new 3-element subsets. And then finally, you can have DE. Each one of these 2-element subsets gives you a 3-element subset, right? So the number of 2-element subsets is exactly the same as the number of 3-element subsets. This is simply because in each case you simply remove what is left. You count what is left. In that case, you will know what is in. All right. So there are 10 ways of doing this thing. Right. Now, so there are 10 3-element subsets. Now, the other way of doing this thing here is to count how many are there altogether. How many 3 elements? You see, a 3-element subset, suppose I take A, B, C, right? And this set here, if I got A, B, and C, I don't count any set involving these numbers. I can't count CAB now, for instance, because it's exactly the same set. Or BAC, I can't count, it's exactly the same set. But if you are interested in the order, you would get ABC, ACB, CAB, CBA. Oh, I'm sorry, I should have had BAC, and BCA. You can start with A, you can start with B, or you can start with C. Now, all of these give you the same set. They give you the same set. So every time you choose, if I add the order in place, then I would have had to choose. The first one can be chosen in 5 ways, the second one in 4 ways, the third one in 3 ways. Sorry, I'm just choosing 3 numbers. So that'll give me 60 altogether. But these 60, you got a lot of repetitions. You see, each group is counted 6 times. If I had A, D, C, for instance, that's counted 6 times. So the 60 elements, if you write it down, you'll count this group here only 1 time. So how many groups have you got? We are really interested. These will give you a single 3-element subset. All these 6. Right? So likewise, you want to know, so the 60 are divided up into how many groups of 6? Answer is 60 divided by 6. Because then you will get the 10. You see how the 10 comes around? You see? Because you got 60 altogether and you are subtracting, you are breaking them up into groups of 6, because each group of 6 is only counted once in a set. In a set, you don't count the elements more than once. This is exactly the same as the set ACB. See, it's the same set. All right. So now that allows you. So how did you get this? Actually, what we had here is the following. If you rewrite this is 5 times 4 times 3. Where does the 6 come from? The 6 is where you take all the possible arrangements of 3 symbols. That's 1 times 2 times 3. That's where the 6 is coming from. See? So now you got a very beautiful thing here, which now tells me the following, that if I want to count the number of 3-element subsets, where I got 8 elements, right? Then I will say I can choose 3 elements I have to choose 3 elements. Suppose I was interested, I want to count how many subsets I can get all together, not subsets, but how many different ways I can choose 3 elements. So 8 times 7 times 6. The first one can be chosen 8, just like we had 5. First one can be chosen 5 times 4 times 3. Here it will be, the first one will be 8, 7 times 6. I got my 3 things, but they are in groups of 6. So it's 8 times 7 times 6 divided by 1 times 2 times 3. See? And that will give you 3 times 2 is 6. 6 goes there. 8 times 7 is 56. So the answer is there are 8 times 7 times 6 ways of choosing these, but then they are coming in groups of 6. So there are 56 subsets. See? So this leads to a very, very important conclusion, because instead of having 8 and 3, if I had a general principle, suppose I said, how many R elements? In other words, a subset having R, not 3, from a set having N elements, right? From a set having N elements, I want to know how many subsets there are altogether. It's a very, very important question. It comes up everywhere. The answer is, well, as we saw, what you have to do is, at the bottom, the number is equal to, remember we had 1 times 2 times 3, because there were 3 element subsets. Now you've got an R element subset, so here you have 1 times 2 times 3, going all the way up to R. See? And then at the top, you'll notice that the number of factors we had 876 is the same as the number of numbers at the bottom. 1 times 1, 2, 3. There are 3 at the top, 3 at the bottom. So you'll start from 8, which is N in this case. And then you keep multiplying by the one below that until you have R factors altogether. Right. So that is the number of R element subsets that a set having 8 elements have, that a set having N elements. N elements. It's very nice. Like, for instance, if you're taking a lotto and you got 50 numbers to choose from, 1, 2, 3 up to 50, right? And you choose 6. You choose any 6 of these. Now you've got 50 numbers, and you want to choose 6. This principle gives you the answer straight away. How many lotto tickets can you get altogether? So you see, you're going to choose 6. That's your R. 1 times 2 times 3 times 4 times 5 times 6. And your N is 50. So it's 50 times 49 times 48 times 47 times 46. How many have I got? 1, 2, 3, 4, 5. So you have to have the same number as 6 here. So you go all the way up to 45. Right? And multiply these numbers, divide by this, and then you will get the number of lotto tickets you have to buy. And I think I once calculated this to be more than 13 million. So these people who are selling lotto tickets, they are not fools. They know that there are 13 million different ways of choosing 6 numbers. And therefore, what are the chances? You got a population of South Africa has got 60 million or something. What are the chances that 13 million tickets are bought, which can actually find the actual, and all of them all must be different. 13 million different ones. All right, so that just finishes the lesson for that thing. Let's get on to question 9. I'm taking my time today because we are still doing last week's problems. And that is what we have decided to do, by the way. We decided to break the session 5 into 2 sessions. Last week, I had to have bought that session after 50 minutes or something like that. So this is session 5 continued, actually. So the numbers will be changing. Just be cautious to say when you're doing the assignment, you have to do the correct assignment. Today's assignment will be session 5 assignment, right? But you will get the assignment question, so you don't have to worry too much about that. Okay, so the next one now, the set has 300 elements. How many subsets there is that altogether? Not just the 3 element subsets, but the 4 element subsets, the 5 element subsets, and all that. So there's a huge amount of subsets that it has, and how many it has. There's a very beautiful, I'm not going to go into the details of this, but all I will say is that the answer is always, if a set has n elements, then the number of subsets is two to the power of n. Very, very simple formula, right? So if you look at the number of subsets of 3, for instance, right? You got the empty set. You have to count the empty set as well. The set which got no elements, or the set which has got 1 element, the subset which has got 1 element, or the subset which has got 2 elements, or the subset which has got 3 elements, right? So these are all the ones. Then you can see I've got 1, 4, 8. You see, you got 8. So there are 8 possible subsets, which is 2 to the power of 3. It always works. If you got 3 elements, there are 2 to the 3 subsets. You can try A, B, C, D, list all the ones there, and you will see that you have 2 to the power of 4. You'll have 16 subsets, right? There is a way of actually proving this, but I'm going to do this quickly. And those of you who can understand it, that's fine. I'm sure many of you will understand the calculation, but the principle behind it is more important. Let's just take all these things out first. The answer is 2 to the power of 300 here, by the way, because n is 2 to the power of 300. You may think it's 2 to the power of 300. It's a very, very large number, guys. It's more, that number is more than the number of electrons in the entire universe. There are less than 2 to the power of 300 electrons in the entire universe. If you count all the planets and all the stars in the galaxies, you're going to get less than that. Let me just explain to you where this formula is coming from. So what you have here is, I've got n blocks to fill in because I want to choose my subsets, and the set has got n elements. So I have to pick, I either pick an element or I don't pick it in my subset. And that's where the clue is. I either pick or don't pick. But there are n of them altogether. Okay, let's just make it n equals 6, yeah? And you'll see how it works. So this case, n is equal to 6. So in a subset, I either pick an element in a subset or I don't pick it. So that means I've got 2 choices, like that. Again, the second one, I either pick that element or I don't pick it. I've got 2 choices there as well. So in each case, I've got 2 choices. And that is why you have to multiply all these things together and you'll get 2 to the power of 6. This is not very obvious. You have to figure out why It is 2 times 2 times 2. 6 times. So, but that is a simple way of explaining this thing. But just very few people will be fully understand why that is the case. Okay, now let's just get on to the next question. Now we're in geometry. Okay, so let's have a look at this first problem. I hope I haven't spent too much of time on all the other things. But just to be on the safe side. Determine the perimeter of the indicated triangle. Now, geometry is very demanding because here you have to use, very often you have to do something which is not there at all. You have to use your intuition, or you have to use your given information, and real problem solving comes in geometry. So here you've got a question here, determine the perimeter of the indicated triangle. So I've got a triangle, its hypotenuse is given, and its area is 11. So its area is 11, the hypotenuse is 10, and what is the perimeter? In other words, if you add up all the 3 sides, what do you get? Okay, so for a start, you have to give names to these sides here. And if you want to make it, oh, what happened there? Oh, I took the wrong one. So if I give names to the 2 sides, the remaining sides, which I don't know, I need to calculate A plus B plus 11. That's the perimeter. Perimeter means the sum of the sides. In any polygon, the perimeter is the sum of the sides. It's not just necessarily a rectangle, right, where you know a formula, but if you take any figure, what is a boundary? If you walk right around the boundary, how far have you walked? So now we don't know, we got 11, but the question is, what is A plus B? All right, so what do we have? We've got 2 pieces of information here. You've got that the hypotenuse from Pythagoras, A squared plus B squared is 100, right? It's a right angle. So at least you've got one equation here. And then you also know the area. The area is half base times height. But if you look at the right angle is there, so you can take half base, take this as base, then that will be the height. And that is why I don't like to call the base. This is not the base. Neither of these are the bases. But it's half a side times the perpendicular height to that side. So you got half AB is the area of the triangle. That's the area. We've got a formula for the area of the triangle. It's half base times height. So therefore, you can say that AB is equal to 22. If half AB is equal to 11, then AB is 22. Okay, so you got 2 equations and 2 unknowns, and you can try to solve them. But I can assure you that when you try to solve them, it becomes very difficult. You don't really know how to solve it because you get a funny looking equation with 4th degree or something like that. You don't have any way of actually solving it. So you'll have to think of some other ingenious way of doing this thing. Right. Now the question here is that you don't really have to solve for A and solve for B. We only need to work out A plus B. I don't need to know what A is. I don't need to know what B is. So this is a very important example of where you must look at the question and see what are you going for. Right? You want to calculate A plus B. I know A squared plus B squared, and I know AB. How can I calculate AB? How can I use this information? You'll know that then these guys appear. I got a message which is saying that my internet connection is unstable. All right, let's not worry about that for the time being. So I know what A plus B squared, there's a formula for it. But now I can break these things up into A squared plus B squared plus 2AB. And lo and behold, I have A squared plus B squared. It's 100 and is 44. So 100 plus 44 is 144. Lovely number, because that's a square. So A plus B is 12. Right. Nice question. Where we can't teach these things. So you can't teach them, because you can make any kind of problems like this, where you have to use the given information exclusion. And there you have to think a little bit and say, how can I do that? Right? That's where the creativity of mathematics comes. We go to the next problem. Which is this one. And it says, yeah, I've got two parallelograms. Okay, they are drawn in a way which you can't, it's not the usual way. You got one parallelogram like this, and you got another parallelogram like that. The perpendicular heights are 5 and 10. So the perpendicular height of the parallelogram is given. All right, so I'm going to draw this thing. I thought I might be able to. Okay, now when you got a parallelogram, and this is all about areas, so we need to know what the formula for the area of a parallelogram is. I hope you know that. The formula for the area of a parallelogram. You know the formula for the area of a rectangle. You also know the formula for the area of a triangle. So what is the formula for the area of a parallelogram? And the answer is quite simply, you take the height of the triangle. Okay, if you take the height, then the formula for the area of the parallelogram is base times height. Base times height. This is h. The area is A times h. I don't know why I've suddenly decided to use reds. Yeah, let's just take this thing out. Okay, so if you want to know why, I'll do this thing very quickly. It's very easy to see why. Because the way to see why is you just simply join a diagonal. And these two triangles have the same area. So the area of a triangle is half base times height. So this is also A. And if this has got a height h, this triangle also got height h, because they are the height from, by height h you mean the distance from this vertex down to the bottom. Right. And that's the same distance. The height for that triangle is that one. So the area of these, the area of the parallelogram is half AH, area of this triangle, plus another half AH, and that is how you get A times H. See? Because the lines are parallel, the heights are the same no matter where you take them. Right? All these, just the distance, we can talk about the distance between two parallel lines, right? Which can translates to heights in this case. All right, so now they were asking the area of the shaded part. So the area of the shaded part, that's also a parallelogram. So we need to work out the area of the shaded part. I need to know the base and I need to know the height. Okay, Now, I've got these two parallel. The height of this parallelogram here is given. You can see this. This is the distance between this parallelogram and that parallelogram. I'm sorry, this line and that line. From here, I'm dropping a perpendicular, and that will give you the height. So the height of this parallelogram is the same as the height of this, because these lines are the same parallel lines. So the height of this parallelogram here is h. All right, but then in that case, this becomes a base. So if I call this base B, the area of the yellow parallelogram, required area, one of these uses disappearing ink. I wonder why they do. We've got a thing like that. So required area So I'm looking at this. I'm now, because this height is given, this is the height between these two parallelograms. So I have to take these as a basis. So this part here will be the base. So this is required area is the base times 10, which is 10b. Base times height. So now the question is, what is this base? Right? It's given here that the height here is 5 degrees. I'm sorry, 5. And this is b. So if you sort of unpack that, I'm going to read. So I'm just going to look at the small part here, and I've got, this is your B. And here you got 30 degrees. Like that. And this 5 is actually the height of this triangle. Because the distance from here to here is also 5. This is a parallelogram, you see. So this height is 5. So now I've got a right angle triangle with an angle 30 degrees, and the hypotenuse is 5. And some of you will know this, but if you use trigonometry, you guys are from grade 10 to 12. So trigonometry will tell you that the sine of 30 degrees is opposite over hypotenuse. There's only one unknown here. And sine of 30 degrees is a half. So you got one unknown, and when you cross multiply, you got b equals 10. So we can solve for b. So the required area is 100. So, so we have to do this problem systematically. You see, you have to ask yourself, what is the question? The question is the yellow area. What is the yellow area? It's a parallelogram. How do you find the area of a parallelogram? It's a base times height. Do I know the height? Yes. One height is given. So do I know the base? No. I have to calculate that one. And do I have sufficient information to calculate that? Yes, I do. And that is how you go around solving. That is what problem solving is all about. Okay. So let's just get to the next one. So here, number 12, you have to find the diagram shows the rectangle inside a semicircle. So there you've got a semicircle and you've got a rectangle inside here. Two vertices of the rectangle lie in the semicircle, as you can see. Two lengths are shown. There's one, this is 1 here, 1 centimeter. There's 4 centimeters. If there are teachers here amongst us, please don't put centimeters, just put 4 and 1. Call it units. This certainly is not 1 centimeter. This is not 4 centimeters. You don't have to put any particular unit. You just say unit. 1 unit, 4 units. Unless you're measuring it, then it becomes a centimeter. But I don't know, even in examinations. So if it's a real world problem, then you'll have to say something. You talk about meters and so on in a real world problem. But this is not a real world problem. So you just put units. Okay, now the question is determine the area of the rectangle. So you need to work out the area of the rectangle. You already got the height. So the question is, can I find this length? Do I know this length? X. So if I call this the length X, then the required area is 4x. So now how can I calculate X? You got a 1 here. So by symmetry, this is also a 1. Okay, let's not do it like that. Let's take the center of the circle. This is a semicircle. So this line here is the diameter. Okay, so this is X, but we got a circle here. So let's call this the radius R. Okay, so the diameter is 2R, or the radius is 2R. Okay, so you've got X here. So if this is the center, so this part here will be X over 2. Or rather, the X, what is X? X will be twice this piece here. I'm trying to bring in the radius somehow into this problem because, you got a semicircle. So this part here is the radius minus 1. This part. So the X, which is the base of this, is twice into R minus 1. So I need to calculate R. If I can calculate R, this X here is twice R minus 1, because there's a 1 here. The whole thing is R, so this is R minus 1. So the base of the rectangle is twice into R minus 1. So can I calculate R? This picture here tells me how to do it. Because I've got my R minus 1 here. And I got 4 here, you see. So if I join this radius, I got a lovely right angle triangle. Right? The hypotenuse is R, and one of these sides is R minus 1, and I have an equation in R. The square of the hypotenuse is 4 squared, which is 16, plus R minus 1 squared, and that gives you a single equation in R. So I can calculate this R. See? So if you expand this, R squared minus 2R plus 1, the R squares cancel. Lovely. So you don't have the square term, and you can calculate R now. 2R is equal to 17. We bring it to this side, and R is 17 over 2. Or 2R is 17, so this is 2R minus 2. X is 2R minus 2. So 2R is 17. So 17 minus 2 is 15. I got my X. So if I got my X, I got my area. 4 times 15. Okay, so all these problems you have to do is systematically. And start from what is your question? I've got a 4 and I've got a base here. Rectangle, area of rectangle I know is length times breadth. The only thing is I don't know the breadth, and you use the given information somehow to get to the breadth, and you can see eventually you get to an equation, and you can solve that equation. Okay, so that takes care of that problem. And now I'm going to go on to the next problem. Okay. Okay, here. You've got this problem here which says that ABCD is a rectangle and AB is equal to 8. I've got this 8 here. And BC is 14. So I got that. A strip of width 2. Oh, no, okay. Now this is the height of this parallelogram. Right, we've seen this before. Its width is 2. Okay. So that's the height of the parallelogram. Now, it has an edge AD. Okay, so this parallelogram is put like this. Now they ask you, determine the maximum area of the strip. So this is an interesting problem. It tells you what is the max. You got a strip which you can draw lots of strips like this, but the distance between those two parallelograms must be 2. That's the only thing that is given. Now, what is the largest possible area that you can have for the strip? Now you can see we're getting into more difficult kinds of problems. Yeah. So that is your strip. What is the area of this strip? It's equal to, let's call this x here, that one. So the area of the strip, why did I call that x? Because I got the height, you see. This is a parallelogram. So the area of this parallelogram is the base. The height is 2, so I'm going to choose this as my base. It's 2x. So now I need to calculate, what's the maximum area of the strip. So we want to know what is the maximum value of x. Now here you see you have to use a lot of intelligence because the x is going like this now. Now you can put x's to be like that as long as you got 1 point here and 1 point there. But the longest value of x will be when you are shooting it right up here, you see. When you take the strip and you place it like this, then you got the largest x. Oh, yeah, use some other things. Let's call this y. Sorry about that. So we want to find the maximum value of y. Right? And the maximum value of y occurs when the strip is set like this, with the largest possible value for that side. Right? You can't make it larger than that, otherwise you have it's going out of you see the height is always 2. That is the thing. That's a constraint. All right, so now I'm calling now I need to work on the maximum. The value of y is square root of x squared plus 64. So I want to find out the largest possible value of x squared plus 64. Okay, so how do you do that? Well, where did I get x squared plus 64 from? Well, actually, if we are calling this x, and that is given as 8. So by Pythagoras, this line here is square root of x squared plus 64. So the base is square root of x squared plus 64, and that is what we want to maximize. Okay, now how do you calculate the x? Okay, to do that, you have to get an equation in x. And the area of this parallelogram will give you the equation. The area of the parallelogram, because we know the height, the area of the palm, PARM is short for parallelogram, is equal to base times height. The height is 2 times root x squared plus 64. But the parallelogram the area can be worked out in a different way. If this is x, it's given that the entire length is 14, right? So this part here will have to be 14 minus x. So you got 14 minus x. If this is chosen as the base, then you've got 8 as the height. So the area of the parallelogram is also 8 into 14 minus x. It's also 8 into 14 minus x. So you can find the area of the parallelogram in 2 different ways. And then you got an equation. You can solve for x. Now, this is not a very easy equation, but I just want you to note, I've got down the solution here. The solution here is, if you solve this equation, you got x is 32 over 3. No, actually, I think the area of the strip on x is 32 over 3. So then you can work out what the the maximum area is by looking at that one. Right. So I'm not going to do that because I'm running out of time. But I've got my equation. You can solve for that equation, solve for x, and you'll end up with I think you'll end up with a quadratic, rather messy quadratic. Okay, so that is one. And then finally, I've got only one more problem. And if you can just bear with me, I'll get to the next problem. And this is the last problem. This wouldn't take any time. So you've got the figure shows 4 semicircles, one with radius 2, and the other has got radius. Oh yeah, okay. You got one circle here which has got radius 2, and the other circles have got radii 1. So the small circles, they are semicircles. So these small circles have got radii 1, 1, 1, 1. And the large one has got radius 2. As you can see, it has to be, because this is 1, this radius is 1 here, this is 1, and this is the center of the semicircle. So that's 1, 1. So the semicircle must have got radius 2. And what is the total area of the shaded region? Now, the shaded region is a very funny region. It's, it's got nothing to do with circles or rectangles or anything like that. So how do you find the area? Again, once more, you have to think about this thing here. And there is an actual way of calculating the area of the shaded region. If you think about this, what you have to do is both the shaded regions are the same. By symmetry, you can see. So let me join this thing. So instead of working out both, I'll just work out one of them. Join that like that. Then can I work out the area of this shaded region here? Well, this is a quarter of a circle. Okay, I can work out the area of this whole quarter of this circle, and I have to subtract this quarter, and then I have to subtract this semicircle together with this. And that makes it a little bit complicated. But suppose I drop another perpendicular here, then I'll have a square here actually. I have a square because if this is a perpendicular here, so this is 1 because the radius of a circle. This will be 1, this will be 1. And now you can actually work out this yellow part here because you've got a square. The square has got radius 1, side 1. So the area of the square is 1. And that includes this part here as well, this funny looking part here. And then plus these two areas are both quarter circles, right? So these are 2 quarter circles. So there's one yellow. I'm saying yes, yeah. One yellow, right? Plus square, that one, plus 2 quarter circles. That one, all circles of radius 1, by the way, right? Will give you quarter of the large circle. I'll use that as a symbol for a circle, right? Now, the yellow is only one which you don't know. The square is 1. The 2 quarter circles give you a half circle. Okay, the radius of this quarter circle, this whole circle is 1. So here you have plus 2. The radius of this circle is 1, and the area of the full circle is pi r squared, which is pi times 1 squared, right? But it's a quarter circle. And here you got a quarter of the large circle, and the large circle has got radius 2. So the area of the large circle is radius 2, so it's pi r squared, so it's 4 pi. R squared is 2. So there is one yellow. You can take it to the other side, you've got pi. And here you got minus pi over 2. Right? Minus 1. That's 2 times this. That's one yellow, but you needed 2 yellows. Now let me make sure my yellow is written properly. Y-E-L-L-O-W. So I'm having problems spelling yellow. So 2 yellows will be 2 pi minus 2. What's pi minus 2? Okay, so that brings us to the end of this session 5, which was a session all by itself, complete by itself. And I overestimated the last session, and that is why we had to split this thing up into 2 parts. I'm 9 minutes late. I must apologize for that, but I hope you learned a few things, especially about counting and how to find areas. You have to break them up into smaller units which you can understand and do it systematically. There's no general formula. Okay? So that brings us to the end of this. Now I'm going to open this thing out to questions. If anybody has got any question to ask, please ask it now. Raise your hand, or you can put your microphone on and you can talk to me. It seems that there are no questions. Okay, so doesn't look as if there are any questions. In the chat box as well, I don't see anything. All right, so.
Prof, I wonder if I could say 1 or 2 things.
Oh, is that Brad? Yeah, okay.
Yeah.
Yeah.
Go ahead. Hi, everyone. Yeah, hi, everyone. Thanks for attending this session today. I'm pretty confident you all got 1 or 2 nuggets. I got quite a few from Prof already. I just want to mention 1 or 2 things based on the course, and I'm probably speaking on behalf of the Durban Center and a few of the other centers. Just a reminder that if any of you want to be eligible for the camp at the end of the year, you have to complete all the assignments. So I know with the Durban Center, a few of you are missing 1 or 2 assignments. You have to catch up. If you don't have all the assignments, you just won't be eligible. And you can just chat to your tutors or your Durban Center manager, or rather your center manager to manage that. And then 3 other things. There's quite a few people who are joining late. I understand it's quite hectic, but if you're joining at 6:15 and you're getting the last 1 problem, it's really not worth. I mean, Prof's put in a lot of time. So try just manage your time a bit better. And there are only 4 sessions left. So believe it or not, it's really fast that this course is going to be done. I see a message that says, where can you check previous videos? If you go onto the SAMF YouTube channel, you can check there. And then I just want to reiterate one more thing that Prof mentioned is there's a Actuarial Science of South Africa competition next weekend. Registration closes on Friday. So if you're keen, chat to your head of maths, chat to your center manager. I know in Durban, we're sending a junior Siyanqoba team and a senior Siyanqoba team. So just pop your center manager a message. And yeah, that's all I have to say, Prof, just to make sure everyone's on the same page.
Thank you very much, Brad. I think this is extremely important information. I'll chat to you. Just remain behind, and I'll chat to you again on some other matter, which is related to what you have said. So, guys, there you are. You can participate in the team competition. Speak to your teachers, and tell them to get onto the SAMF website, and there you'll be able to register your team. You can have an entire team taking part, and you will go into the into a very interesting competition where you got 10 people who are participating together as a group, and you compete with other people around the country, which will be quite an exciting thing. And it's only one day, next week Saturday, on the date is 15th, if I'm not mistaken, of September, on the Saturday. And yes, I'm simply repeating what Brad Savage just said. Thank you very much for that. All right, now we're going to close up, and Kagiso, you can stop the recording. And if Kagiso and Brad just remain behind, I'd like to speak to you guys. The rest of you can just sign off, please.
Good session, Prof. It reminds me of all the things I use for counting principles with the matrics. There's so many good questions you can actually put into the matric syllabus with this problem-solving course. It's awesome.
Yeah, very nice. The one about the NCR, that's beyond the syllabus. But I thought because the question came up and that it comes up in competitions, not in the school syllabus, I thought I might just quickly explain, where the formula came from. Well, actually, it wasn't quick. Normally, I would take a whole lecture at the university to describe that, but we had to do that quickly. That is not
It's really
but
good.
the other ones are quite nice.
Yeah, it's really good to extend a top set. And then like at St. Mary's, our further study elective is the stats module. And it just leans so nicely into the statistics and the counting methods and principles. It's really good.
Yeah, okay. I'm glad that you enjoyed that. Those there are some simple ways of doing it, but in most cases you have to think about it.
Yeah, 100%.
I struggle with some of these counting problems myself. Brad,
So,
the reason why I asked you
what's up?
Stay on is that I'm training people. I don't know whether you know about that. I'm training the juniors for the team competition tomorrow, and only 1 2-hour session. I've selected some questions from the team papers. Some of them might actually have been here in our session problems, but whatever. So junior, I've got a 2-hour session that our what's his name, Daniel Kripanandan, he runs a program. I think it's an AMISA. He trains AMISA kids. But I'll be very happy to have you also in that class. I can send you the link if you're interested. And then
yeah, that'd be awesome. Do you want me to invite students as well?
Yeah, I will send you the invitation, so you don't have to worry. Daniel is doing most of the paperwork, but if you're he probably does not have. Which school are you in?
I'm at St. Mary's in Durban. It's down the road from Kersney. It's Kersney's sister school.
Oh yeah, you see, he told me that the Kersney group, Mark and Ciolati, I think he's organizing a team there, but you are staging a separate Siyanqoba team, are you?
So no, the Kersney's joining us. We're hosting. So we hosted last year and we're doing it again this year. I think so far we have about 130 kids who are registered to come through to us next weekend. We're expecting about 150, which is awesome.
Wow. Look, I cannot take all that because I've got a free version of Zoom. It only allows up to 100. And
I don't think they'll all attend, but what I'll do, Prof, is I'll send it to all the teachers who have registered their kids, and I'll actually put the ball in their court saying, listen, please share this with your students if they're keen. If I had to be honest, I don't think a lot will join, but it's just giving them the opportunity. You'll just need a handful to really come through to experience it.
Well, hopefully, yeah. Otherwise, if it shoots over 100, and I get bummed out, then I wouldn't know what to do.
I'll leave them, Prof. Don't worry. I'll leave and you can teach.
All right. So I'll send you the links now.
Yeah, you can just email it to me and then I'll manage everything from there.
Okay, great. Okay. Thank you so much.
Is there only a junior session that you're having, or you're going to
No,
have
no,
a
there's a
session for the
senior one
seniors as well?
on Friday as well. Yeah.
Oh,
So I'm going to
perfect.
Tuesday
Yeah,
and
that's
Friday.
awesome.
No, wait a minute.
Yeah,
Tuesday and Friday. Yeah, Tuesday and Friday. Yeah. Okay. Yeah.
Okay, perfect, Prof. You can definitely send it through to me.
Okay then, Bradley. Thank you very much, and you take care.
Yeah, cheers, guys. Cheers, everyone.
Okay, bye. Kagiso, are you there? I'm sorry I took your time. Kagiso.